sure they can hear you.
Yeah. If you can't hear me, just confirm so that I can just speak up a bit. Yeah.
Oh, it's great now.
Awesome. Wonderful. All right. So just like I was saying, we're gonna go through the requirements of the project, and then we'll know exactly what the project is looking for. Now, when you get that in-depth understanding of what is required of you, then you can actually go ahead and then implement those instructions in code. So I'm just gonna go ahead and share my screen, and then we're gonna kick off. I hope you can see my screen. Abina, can you see my screen?
Oh, sorry, I was
If you
talking
can
on
see
mute.
it.
Yes, I can see it.
Wonderful. Okay, so let's start. Let's just jump right in. What is this Printf project looking for? Last week, Friday, Saturday, my partner and I, we went ahead to show you how to collaborate on GitHub, how to push and pull, and all that. So I believe you guys are quite familiar with that now. If you're still having struggles with that, we're going to allocate some minutes to questions and answers so you can access when that time comes. But for now, I'm going to use a few minutes to run through the slides, and then when we are done, if you have any question, you can just bring it up so that we see how we can figure it out together. So let's see. I have 3 tips for you over here. The first thing you got to do first is to understand the questions very, very well. This is the secret of the project. A lot of people are kind of struggling because the questions seem vague. Like they don't really know what is required of me. They says that the project is saying that I should implement this and that. I should handle this format specifier. I don't even understand the question to even try to start something. So the very first step that you need to take is to make sure that you have a very good and in-depth understanding of the question. When that is settled, about 50 to 60% of the task is done. Right? Then when you now understand the question, you now want to brainstorm the logic for each task. Okay? At this point, you understand the requirement. Then when you're done, the third tip is to organize and name your files according to the functions that you're going to create. The moment these 3 tips are settled, I think somebody got to mute their feed. If you can hear me, kindly mute your feed. Then the third thing you got to do is to now organize the name of your files according to your functions. When these 3 things are settled in your mind, I think you're good to go. So let's quickly run through the task and then we'll see what exactly you need to do. The first task said that you write a function that produces output according to a format. Then you are given the prototype. You are given the prototype of the function, and this is your prototype, which is underscore printf. Okay. Now you were also asked to return the number of characters printed, excluding the null byte. All right. Then you were also asked in task 0 to write the output to the standard output. All right. Then you were also asked to format the string. Sorry, you are also asked to format the string such that it contains 0 or more directive. Then in that same task, you were asked to handle the following conversion specifiers, which is C, S, and the percent sign itself. Now, a lot of people are asking questions, and I actually go through the questions on Slack, and then I've put some of the questions together so that we can try and tackle them in this presentation. People don't really understand what is going on. Like, how am I even supposed to start all these things? I don't even understand the printf functionality for these things that I'm seeing here. And that is the purpose of this presentation. So let's just try and break it down. Okay, now, what does it mean to um, return the number of characters printed by your printf function? And why this prototype? Why are you writing it to the standard output? What does it even mean for the string to be composed of 0 or more directives? Let's break it down. So in order to do that, I'm going to take you into the project itself, and I'm going to show you this gray box that you see over here. Usually, when you come into the project, you're going to see that Julian will be trying to show you, this time around, we are dealing with Alex anyway. He'll be trying to show you how the output of your code is supposed to be. So this you're seeing here is a test file. and the name of the test file is main.c. Okay, so the cat function is simply a shell function that tells you the content of the file main.c. This simply means that everything that you are seeing inside this file is just the content of a certain file called main.c all the way to this point. All right, so everything you see over here is just the content of the file main.c. Let's break it down. All these you see here are just comments, these are just header files, but the real thing I need you to focus on is beginning from this point. Now, the printf function that you are going to create is going to be put to the test, and it is going to be compared to the printf of the standard library. Okay, so I want you to pay attention here. Look at here, this one carefully. You're going to see that this printf starts with an underscore. Okay, but the second one does not have any underscore. This simply means that this printf over here is the printf of the standard library, the one that we were using all the time. And this first one over here is the one that you are going to create. Now, if you look at it carefully, both printfs are being put to the test. So here in this case, this len variable, which is an integer variable, okay, it is being asked to print this string, as you can see over here, with the custom printf function. That one starts with an underscore, okay. Now, the second printf function, which is the printf of the standard library, is also put to the same test, and we realize that we get the same output over here. So these are the two outputs. The first one is for your custom printf, and the second one is for the printf of the standard library. Right? So in order not to waste a lot of time, I would have worked with VI, but we don't have a lot of time. We only have an hour today. So I'm going to be using VS Code to run the example so that I can move really, really fast because we don't have a lot of time. So assuming I wanted to print a function here with a standard library printf, all I have to do is to say I want to printf, let's say my name. So I just say my name is Leo. Okay, very simple with my semicolon. Now when I run this code in the terminal, you realize that it's going to print out for me that my name is Leo. Just as you see down here, my name is Leo. I'm going to clear the terminal, right? Great. So basically, this is the functionality of printing out an output string. This you're seeing over here, the argument that I've given to this printf function is what is known as an output string. So the requirement of the first task over here is simply telling you that your string or your printf function is supposed to return a format according to a string according to an output format, which is the first instruction that was given to you, to write a function that produces output according to a format. That format is a string. And then you are given this prototype, and this prototype simply tells you that this function that you are going to implement is a variadic function, and that is indicated by these three ellipses you see over here. And I believe that my other learning ambassadors have done a very good job on variadic functions. So we also have resources that we have left for you guys that you can get familiar with variadic functions. So you should make time and read on that, and then it will become very easy for you. But that is not our focus here today. All right. Now, look at this thing carefully. It says that the function that you are going to implement has to return the number of characters printed, meaning that this integer return type you are seeing over here, you are supposed to track it within your code so that every format or every string that you give to your function is going to be counted. Now listen to that carefully. Every format or string that you give to your printf function is going to be counted. So your code is supposed to be able to return the number of. Yes.
That,
Is anyone talking?
that's okay. I've muted them so you can go on.
Awesome. So your printf function is supposed to be able to return the number of characters printed. Let's see how the printf of the standard library is able to do that. So here in this case, I printed my name is Leo and it gave me the output. Okay. Now watch something. Instead of just printing this, we are going to print this printf. Okay. So we're going to print f, the printf that we already printed. So I'm going to use the format specifier %d. Okay. Great. And then I'm going to print this printf. Okay. Now watch this. I need to give it my parenthesis over here. Great. So I have my first parenthesis here. I close it over here. So now watch what's gonna happen when I print this out. You realize that it does not just give me my name is Leo as the output. The printf function is also counting the number of characters in the string, and then it returns the number of characters in the string. So that lets you know that the printf function itself tracks the number of characters within the format or within the string. So when you give the format your function, when you give the function your format, you're not only supposed to be able to print out a string, you're also supposed to track the number of characters printed by the function. And that is what the first task is requiring from you. Then also you are supposed to print it to the standard output. This means that you know that you have to look for a function that is able to print text to the standard output. Printf does that. Go through the list of functions, you're going to realize that you have some of the functions, such as the write function, that can print text to the standard output. And that is very cardinal. Now, when we talk about the directives of your format, anytime you have um, um, a format or a string given to your printf function as an argument without a format specifier, it means that there are zero directives in the format. For instance, this first printf you are seeing over here has zero directives because there is no format specifier. But this second printf function you are seeing here has one directive, means that it has one format specifier. So anytime you hear zero or more directives, it's simply talking about the format specifiers that is given to your printf function to print out. Okay, that is very simple and straight to the point. Then now finally, it is asking you to handle the format specifiers C, S, and the percent sign. And these are also quite straight to the point. All you have to do, if you want to print a character, use the percent C. Then let's say I want to print the character W. Usually it's in single quotes. Now when I print this out, it's just simply going to give me the character W, as you can see down here. Okay, that is what the percent %C character does. Then you're also asked to handle the percent %S. So with the percent
Yeah.
%S, yep,
Oh yeah, I was saying let me interrupt you briefly. So please go back to your terminal, right? Um,
sure,
the example that you were showing.
this one.
Oh, okay. So I just wanted to like draw their attention to something quickly. This is something that we handled in our previous session on Saturday about format specifiers and special characters and everything. So I will link the resources to the previous session to this meeting later. I want us to focus on this, but I just need you to see something. So it's just because you're talking about the format specifiers and then the special characters. So you notice how because he's not using the new line character, every time he prints something, it's like what's the word?
It's
It,
together,
it just immediately
yes,
attaches to the yeah.
to the
But
username,
if he
yes.
to include a new line, which is a special character, then it will properly format his output. So that's just something that you have to know. Like to write a proper printf function, remember to include the new line. And yeah, exactly. And I'm going to share the link. I feel like maybe if I share the link, you might get distracted and want to click on it. So I want us to focus on today's session. Then towards the end, when we are having the questions, I'll just include the link. Yes. So basically, you can go on. So you get to see what the percentage sign, the C character, the D, and everything, what they do and what they print. That was in our previous session. So yeah, Leo, you can go on.
Wonderful. Thank you for that wonderful addition. Exactly. So you realize that, as she said, now I've added a new line character. Now when I print the output, the sorry about that. Where's the error coming from? Great. So I added a new line character to it. You realize that now it's appended a new line to the code. And that is very critical. And that is for the percent %C, which prints out a character. If you want to print out a string, you use percent %S with double quotes. So let's say I want to print out a string, which is, let's say, printf project. Now, when I run this code, you realize that it's going to give me the output of a string, which is right here, printf project. Now, for the percent sign, assuming I wanted to print the percent sign to the standard output, you're going to realize that if I try to print the percent sign alone without any um, effort to try and escape it, I'm going to get an error. When I print this out, you realize that it says one warning generated, because the percent sign, as Abina was saying, there are certain characters that are special characters, and we handled that in our previous session as well. So if you want to escape a special character, there are ways by which you go about it. So now in your code, for you to implement the percent sign, you need to ensure that you add the logic such that the percent sign will be escaped by a percent sign. Okay? And that is very simple and straight to the point. So now when I print this, you realize that I get the percent sign printed to the standard output. So in summary, what the first task is asking from you is just make sure that you can print a string to the standard output. Make sure that you can handle the format specifiers for a character, a string, and the percent sign itself. And it's as simple as that. Now, for the second one, it's a similar task to the first one. All you have to do is to handle the conversion specifiers for %d and %i. And as you know, this one prints an integer format it prints out integers, and this one also, the I also prints out integers. Okay, just that the I has a more versatile functionality than the D format specifier. You can use the I to print other kinds of integers, especially when you add certain flags to it. But then the D is the general format specifier for all integers. And this one is also pretty straight to the point. All right. Now, the task 2 is asking you to handle a custom conversion specifier, and I will need you to pay a lot of attention here. Now, for this particular task, it's telling you that when you input the argument, which is an integer, an unsigned integer, the argument will be converted to a binary number. So when you look into the project, an example was given over here within that particular task, which is task 2. And you're going to realize that an integer, which is the number 98, is given to this custom format specifier. All right. Then the output was a binary output, which is a binary number. All right. Now, I'm going to go into one of the tests. Okay. This you see over here is just simply everything that is inside the gray box that I've copied into a file over here. All right. So I'm going to try and run one of the requirements of the task, which is the %b, for you to see exactly how the output is going to be. So for this particular test that you see over here, I'm declaring an integer called number with a value 7, and I'm going to use the custom printf function, which you are supposed to create, and then you implement the code logic such that when you enter %b and enter the variable, which is the number, the output is supposed to be converted to a binary number. So I'm just going to compile this gcc. Okay, I'm going to compile all C files, all .c files, and the output is going to be given to a.out. So I'm going to execute a.out, and then you're going to see that the binary notation for 7 is 111. Assuming I change this figure to, let's say, any number at all, let's say 20. Okay, 20. Then I'm going to recompile again. So I'm going to gcc all C files. Let me clear the terminal. Then I'm going to run a.out. You're going to realize that this integer 20 has been converted to its corresponding binary notation. So that is the code logic that you are supposed to implement for the second task. That is what it is requiring of you. All right? Without wasting any more time, it's very simple and straight to the point. So what you got to do is you go and look for the understanding of how to convert an integer to a binary figure and then implement it in your code. Very simple and straight to the point. Now, the third task is asking you to handle conversion specifiers, just like the %d and the %i. The %u is
Leo, sorry.
yes. Go ahead.
Sorry, someone is saying they can't see the screen. I don't know if I can see your screen. I don't know if it's a general problem or they would have to. Um, please, please react with a thumbs up or something if you can see your screen. Just a few people will be fine. Okay, so I think it was Damilula.
Okay.
I think you might have to exit and rejoin. Maybe it's a network issue. Sorry, go on.
Wonderful. Okay, so just like I was saying, these are other format specifiers that the third task is asking you to handle. There is a U, there is a O for the octal, there is a X for the hexadecimal, and then there is a capital X for the hexadecimal caps. Let's demonstrate these and let's see how they go. So right here in the same code, I think somebody got to mute their feed. Let's use the %u to print out the same number, and you see the output. Okay, so I'm just going to recompile all C files and then execute it with a.out. And you're going to see that it just gives me the number straight to the point. Now let's try the %o, which is for the octal. So I'm just going to clear my terminal. I'm going to compile all C files, then execute the executable. You realize that the number I gave to the compiler is 20, but I'm getting an output of 24 because it's converting it to an octal number. Just as we have binary, ternary, and then quaternary figures, the octal is simply base 8. So let me increase this figure a bit so that at least you can have a fair idea. So in integer, I've added a figure which is 8 to this integer I'm giving to the variable number. And I want to print an octal notation with my custom printf function which I've created. This is not the printf of the standard library. It's my own printf function which I've created, okay, which I'm using to demonstrate how your code is supposed to work. Okay, so I just give this integer to this variable and I want to print it with the octal notation. So I'm going to clear my terminal and recompile all C files, then execute the executable. You're going to realize that the output that I'm getting is always going to be less than 8 because base 8 is going to range from 0 to 7, just as binary numbers range from 0 and 1. Okay, and that is very simple and straight to the point. Now let's try it with a small x, which is for the hexadecimal. Now I'm going to clear my terminal and then I'm going to recompile all C files. Then I'm going to execute the executable. Realize that it's been converted to a hexadecimal notation. Let me increase this figure, all right? Let me just give it more numbers and then recompile. And then let's see what we get. Now you realize that because I've gone beyond the range of an integer, it's giving me an error. So I'm just going to reduce it, clear my terminal, and recompile. So all C files, then I'll execute the executable, a.out. You realize that I'm getting a hexadecimal notation. But this time around, I'm getting the figures in small cases. And that is what the X format specifier does. So when you change the small x to a capital X, now I'm going to recompile all C files. Then I'm going to execute the executable again. You realize that the same figure over here as a hexadecimal number with a small d, this time around I'm getting the alphabet in capital D. So what the capital X format specifier does is that it prints out the hexadecimal number with capital letters, and then the small x prints out the hexadecimal number with small letters. And I just hope you know what hexadecimal numbers are. They are really simple and straight to the point. They are just a number base that ranges from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then from 10 the figures are not used anymore. 10 becomes A, 11 becomes B, 12 becomes C, 13 becomes D, 14 becomes E, and 15 becomes F. So the hexadecimal numbers range from 0 to F. So anytime you're going to print a hexadecimal number, it's going to range from these figures. Now, this simply should let you know that when you're going to implement your code logic, you're going to implement a figure that will range from 0 all the way to 15, which is denoted by an F. And then you're also going to implement, so for the capital letters, you're going to do it for the capital X. And for the small letter range, which is A, B, C, D, E, and F, you're going to do it for the small letter X. And that is really simple and straight to the point too. Alright, so that is it for these format specifiers. Now for the fourth task, you are asked to use a local buffer to be in order to call the right function as little as possible. What does that mean? Now simply what you're supposed to do with that is that remember that the write function is what you're going to be using to write text to your standard output. And then you already know the notation for the write function and how it works. Okay? Now, instead of calling the write function whenever you want to print text to the standard output, you're going to declare a buffer, which is going to be like a box, like an array of characters. Okay? Then the capacity of that array is going to be 1024. So this buffer can hold 1024 characters. And then when the buffer gets full, you just empty the buffer with a write function to the standard output. Very simple and straight to the point as well. Okay. Now the next task is asking you to handle custom conversion specifier. You're supposed to do for the character capital S. Now, whenever you are reading the task and you see custom conversion specifier, this should let you know that this specifier does not work with the usual printf function. You are supposed to come up with a code logic to be able to execute or implement that functionality that they are requiring. That is very critical. So if I go into my VS Code right now and I try to print anything with a format specifier capital S, it's definitely not gonna work. Okay, let's say I want to print the string name or anything. When I run this code, it's gonna tell me that it does not recognize %capital S. What it knows is %s, small s. Now, this simply means that in your code, you're supposed to come up with a logic that implements this. And what do you see here? It says that this format specifier capital S is supposed to print the non-printable characters in the ASCII code. I'm going to show that to you right now. Then the non-printable characters range from 0 to 32 or above 127. Okay? Then what they want you to print is whenever the compiler comes across a non-printable character, you're supposed to replace it with \x and then 2 characters of the ASCII code. But what is all these plenty things that they are trying to confuse you with? Okay, I'm going to explain it to you. And then this is the input, that example that they gave. So let's say this is a new line character notation, all right? So they are trying to print best school with a new line in between. And instead of a new line, the output becomes \x with the ASCII notation of this non-printable character. Let me show you something. What do I mean by that? I'm just going to go straight into my terminal. Okay. Then I'm going to man ASCII. All right. Now, when you man ASCII, the ASCII table is going to be printed to your terminal, and you can see all the ASCII characters and their corresponding values. Like I told you, the non-printable characters range from 0 to 32. So if you look at this, 000 corresponds to now, right? So we go all the way to the number 32. Those are the non-printable characters of ASCII. Very critical. So as you can see, the new line notation corresponds to this figure. And then there are many other non-printable characters in here. As you can see, A corresponds to the number 65 and on and on and on. Maybe I should just minimize this for you to see. When you come in there, don't focus on the octal set. Just focus on the decimal set. There are various ASCII sets in the manual. This one has to do with the octal set, okay? So don't focus on the octal and the hexadecimal. Focus on the decimal set. That is what you need, all right? So you can see that within here, the new line character corresponds to 10 in a decimal set. Okay. Then, for instance, a character like A in ASCII corresponds to the number 65. Now, what are you supposed to do? The question says that whenever your compiler comes across any value within the ASCII figures ranging from 0 to 32, it should print \x and replace it with the hexadecimal correspondence of the ASCII value. What does that mean? Let's try it out. So, for instance, I want to print best school with a new line character. Now look at it here. The new line character corresponds to the value 10. Okay, it corresponds to the value 10. So what is your code supposed to do? Now I go into my custom printf function. Now let's try it out. So instead of printing best new line school, I'm going to use the format specifier %S. I forgot my code, sorry. %S, and I'll try and print best school. Okay. Now when I run this code, so let me just come into my terminal, clear it up, compile all C files, then run my executable. You're going to realize that immediately, instead of this new line character giving me taking the school to the next line, it doesn't happen that way. It rather replaces it with a \x, all right, and then gives me the corresponding ASCII value for the new line, which is A. Remember that in hexadecimal, A is 10. This, like I explained to you guys over here, all right. So 0 all the way to 9. When we are coming to the figure 10, it becomes A all the way to F. So in hexadecimal notation, A is 10. So the output that I'm getting over here, remember that when we manned ASCII as well, the new line notation corresponds to the value 10. And the question that you were giving says that the non-printable character, which ranges from 0 to 32 or greater than 127, I'll explain that too. They are supposed to be printed with a \x followed by the ASCII code value in hexadecimal, uppercase. Okay, so now the 10, which corresponds to the new line character, is going to be converted to ASCII. Is going to be converted to the hexadecimal notation, which we have realized is 10. And in hexadecimal, 10 is A. So that output you are seeing over here, not this one, this one, this one. This output you are seeing over here is simply this new line notation between best and school being printed as \x 0A, which is the hexadecimal correspondence for the value 10. How are you going to do this in code? This will simply let you know that, okay, now I need to go and find what kind of code can convert a non-printable character to hexadecimal figure. Then you go do your research, and it's actually very easy to come across such information. The resources are out there, and it's so simple to come across such information. So right there, when you understand what the question is asking for this way, you now go out there and you're like, what kind of code can convert a non-printable character to its hexadecimal correspondence? Then you have your answer right there. Implement it in the function, and you're gone. I feel like I'm giving you too much, but I mean, you need it, and it's very needful. Now, the next question says that handle the following conversion specifier, which is P, and I'm sure this is you are very familiar with the %P format specifier, because all it does is that it prints the address of any variable. So let's say I want to print %P of this string. Now, when I run this code, I'm immediately going to get the address of this variable. Okay, let me just clear my terminal. Not capital P, small p, sorry. So I'm going to print this out, and you're going to realize that I have the address of this string. So how are you going to implement task 6 in code? All you have to do is that how do I create my own format specifier that can print out the address of any variable? And such code is actually very simple to come across. All right, so I'm not going to waste a lot of time here. Then task 7 says that handle the following flag characters for. Now take note of this, non-custom conversion specifiers, which means that you are going to implement this for the format specifiers that are part of the printf of the standard library. I hope that is very clear. What does the plus do? What does the space do? What does the hashtag do? They are very simple and straight to the point. Now, for instance, if I want to print an integer, so let me declare an integer and call it number. I'm going to assign the value 47 to it. Okay. Now I want to print it with %d. But this time around, I'm not just going to print the variable. I'm going to add a flag. Okay. So instead of just saying %d, I'm going to say % plus d. I hope you are watching there. % plus d. Now, when I run this code, you realize that the output comes out and then there's a plus sign in front of the 47. There's a plus sign in front of the 47. Let me clear this terminal and run that again so that it comes out clearly. So you see, so what are you supposed to do in code? You are supposed to write the code logic such that when the compiler comes across the format, the plus sign, it is going to assign a symbol plus to the number or the variable that you have given to it. Really, really simple and straight to the point. Then, not just the plus sign, but you can also work on the space. So I'm going to put a space here, just like the second requirement in your task, and then I'm going to run this code with a space in between the percent and the format specifier, and you're going to see what happens. Immediately, you're seeing that there's this space that has been created here right in front of the variable, the number, which is 47. But if I increase this space, and I make it very big between the percent and then the number, I'm going to run this code and you're going to realize that it's still the same. When I increase all this space, it was supposed to implement it here in front of the number, but I still don't get any space. But now watch something. I'm going to make this number a negative number and I'm going to run this code again and see what happens. The negative number fills up the space that I have allocated to the variable. But if it is not a negative number and it's a positive number and I run the code, you're going to realize that it just gives it one space. No matter how long the space is, it just gives it one space and then prints the number. That should tell you that now how do I implement this in code? I have to ensure that when the compiler for this particular flag, when it comes across the space, it should assign just one space and then continue the code. I just hope these things are making sense to you, but let me just rush through it so that I can come for questions when I'm done. How many minutes have I done? 43. So I'm going to wrap up in the next like three minutes so that we can take questions. What is the next task? Okay, great. Then there's also the hashtag flag that you're supposed to implement. The behavior of this flag depends on the specifier it is paired with. So for this particular flag, if you pair it to %d, it behaves a different way. If you pair %f, it behaves a different way. So usually what you want to do is to go in there and then try it out. So I'm going to delete this space and put the hashtag over there. Okay. Then I'm going to run this code and then let's see what happens. It gives me the number 47. Let me just clear this terminal. I'm going to run it again. It's actually giving me a warning. I don't know why it's giving me a warning, but it's not supposed to. But then let's try it with a float, okay? Let me change this number, integer variable, to a float. And then we're going to use %f. Then between the percent and the f, we're going to bring a hash tag. And I'm going to run that code. Now you can see that it is giving me a certain number of precision of my float variable. Then you can also add any number of precision that you want. Let's say you want it to second 2 decimal places. Now when I add the precision, which is determined by the decimal, it only gives me 2 decimal places. So how are you going to implement this in code? You're going to tell your compiler that when you come across the dot or when you come across the number, assign this so and so number of spaces to it, or the figures to it, or the flag to it, or the addition. Actually very simple and straight to the point. Then finally, the other flags that you're supposed to handle are the L and the H. When you add an L to the format specifiers DIUOX and then the capital X, it formats it as a long format. So D represents an integer, %d is an integer. So if I say I add L, let's say %LD, then I'm going to have a long integer. If I say %LI, then I'm going to have a long integer, that also has special characteristics. If I say LU, I'm going to have a long unsigned integer. If I say LO, I'm going to have a long octal, and so on and so forth. Now, the next thing that you need to take note of is the H, which formats it as a short. In the same way, let's say I put the H in front of the X, then I'm going to have a short hexadecimal number. Also simple and straight to the point. Then now you're also supposed to handle the field width for non-custom specifiers, which are the same as these ones. All right. Then the field width, just like the precision, all you have to do to declare a width is to, let's say I want to print out an integer, which is the number 47. All I have to do to declare a width is to add a number between the percent and the D. So I'm declaring a width of 10 over here. Now when I run this code, before the number, there's going to be a long space over here. Just for you to see clearly, let me put these vertical lines over here and run the code again. You're gonna see these this long space in front of the number. This is what is referred to as the width. So in your code, you're supposed to say that if you see this number for the width, assign this so and so number of spaces. The width also works for strings as well. All right. Then the task 10 says that you should handle the precision for non-custom conversion specifiers, and I explained the precision as a decimal figure. So if you add 0.2, then you get 2 decimal places. The task 11 says that handle the zero flag character for non-custom conversion specifiers, and that is also very simple and straight to the point. To handle the zero character, let's say I want to print this %d, this number. So %d, then instead of just printing the number 47, I'm going to add a 0 in front of the %d, and then I'm going to add a width, let's say 6. So when I print this, you're going to realize that zeros are now preceding my output. Zeros are now preceding my output. So to handle that kind of code, you have to look for the code that now, when you come across the width with a 0 in front of it, append zeros to the output. That's actually really straight to the point to do that too. Then the task 12 says that handle the flag, the dash flag, which also works like the plus flag. All right. The task 13 says that handle the following custom conversion specifiers, which is R. The R prints a reverse string. So now for my custom printf function, let's say I want to print the string Abena. So I'm gonna print Abena. Then instead of using %s for string, I'm gonna use %r. All right. Then I'm gonna run this code. Then you're gonna realize that, just hold on, which format specifier was that? It's small r, right? Great. So I'm gonna run this code. Where is it? Great. So I'm gonna run this code with %r and try and print Abena, and let's see what we get. I'm actually getting an error. I don't know why. Let me try it again. I'm having an Elinka error. So let me clear my terminal and run it the normal way. So I'm gonna compile all C files. Then I'm gonna run my executable a.out, and I enter. So you can see that Abena has been printed in a reversed format. Okay, instead of Abena, now I'm getting Abena in a reversed format. And the reason is that within my own printf function, I've implemented the code, which I'm not going to show you here, such that, and moreover, if you go into my GitHub, my printf function is hidden anyway. I've implemented the code such that now, what are you supposed to do? Go into the code and then go and look for the, actually you have already done this print. Let me give you a key. Just go to strings, arrays, and pointers. One of the questions was to create a function that prints a reverse string. That is the code that you need. And then you're going to use that code to create a function and then assign it to the format specifier R. That when you come across the format specifier R, then you put in the code that reverses a string. Very straight to the point, very easy. And the final tag says that handle was anyone saying anything?
No, go ahead. I was just like, you have about 10 minutes to go, but yeah,
Yeah.
take some questions.
Yes, ma'am.
But
So,
just wrap it up.
yes, ma'am. So the final tag says that you should handle the conversion specifier capital R that prints the rot13 string. What is the meaning of that? That's also actually very simple and straight to the point. So, what is the meaning of the rot13 string? Assuming I have alphabet A to Z. All right. If I write the name Abena, okay, when the compiler is gonna print Abena, it's gonna count 13 characters and then replace the A with that character. So if A is 1, then we have B, C, D, E, F, G, H, I, J, K, L, M, N. So we are gonna count 13 steps forward and it falls on N. So instead of A, the compiler is gonna print N. So it's gonna do the same for all these characters. Instead of printing these characters, it will go forward 13 times and then um, replace these characters with the 13th character ahead. So instead of this, you're gonna have an encrypted output, something like this. So now let me run that final code and let's see what happens. Let's say I want to print Abena, but this time around I'm not using the format specifier capital small r. I'm using capital R because I think that's what the task was requiring, right? The 14th one is what? Capital R. Great. So I put in my capital R and then I'm going to clear my terminal and recompile all C files. Then I'm going to a.out. And instead of having Abena printed out, I'm having the encrypted version of Abena, which is Noran, printed out. And when I rerun this code, I'm going to have Abena back. So guys, basically, that is all the task. And the final task 15 says that all these things must be able to work in synchronicity. Okay. So basically, this is what the project is about. Okay. So now, if you have any difficulty or any question, once the question is clear and broken down, then you can have a fair idea of, okay, now I know how to go about this and that. So let's open the floor now, and if you have any question, we can take it and help you out. I'm just gonna stop sharing my screen.
Okay, so okay, right, great. Thank you so much, Leo. That was really um a great presentation. I hope everybody listened to the parts when you got the tip. Hey, I think I posted a YouTube video in the chat about the width and precision and stuff, so you can take a look at it. I've also posted the link from previous session, the previous session we had on Saturday explaining format specifiers and special characters and how to collaborate and everything. So yes, do look in the chat box and then find all these necessary resources. In the 7 minutes that we have left, let's try and answer some questions. So if anybody has a question, unmute your mic, go ahead, ask, or just put it in the chat box and let's just get going. We don't have enough time. So anybody, if you have a question, just come on and then let's hear you. Okay, Leo, I think someone is asking. I think Christian is asking about implementing all the features and not exceeding 40 lines of code. I think that question has been answered on the channel. I will find the resolution to it and tag you on it so we can skip that for now. I think someone was trying to unmute their mic. Hello, does anybody have a question?
Hello, I was asking the same question.
About the 40 lines?
Yes, yes, yes.
Okay, so I mean, from my experience, the best way to handle such an issue is to break down your code into functions and then call the function into whichever particular code that requires that lot of lines of code. Um, you
Yes, yes, yes,
that's
exact,
how to resolve that issue, right?
exactly. So most of the people that are having the issue of the 40 lines function are using switch cases. 95% of the time when you go into their code, you realize that they are using the switch case instead of the if else statement. And the issue with the switch case is that you're going to keep going on and on and on and on because you have to implement a case for each format specifier. So just like Abina said, the trick to the way to go about that is to just instead of putting all the files in all the format specifier code in one long function for one single file, go into another file, create the function within that file. So the function will definitely have a name. And you come into your main source code file. You're gonna call the name of that function with its necessary arguments in that main source code file. So that way, you're going to have your functions in different files, but they are all going to be interconnected in one main source code file. And because you are going to include your main header file, which is shell dot, is it main.h or something? I think the simple shell project has gotten into my head. Um, so you're going to
Yeah,
it's main.h, right? So you're going to include your main.h in all those new files you're going to create that will contain new functions. That way, you're not going to have more than 40 lines of code in just one file. I hope that helps.
Thank you. Thank you. If I don't have any question, I'll go to it. Thank you.
Ronald, Imad, hi Imad. Imad has his hands up. Please
Uh,
unmute your mic.
oh, hello. Hi, guys. Sorry, I just
Hi.
coming. Yeah,
Oh,
yeah. How's it going? Everything is okay?
yeah, we just ended. We are taking questions. Leo gave a
Mm-hmm.
really great presentation. So we are going to add the resources to your repo, and then when you share, people will have access to it.
Mm-hmm. Yeah, I can share with the people the repo. When you add the resources, I'm gonna accept the request, the full request.
Yeah, I think I did a pull request on Saturday and it was
Mm-hmm.
accepted. I'm
Yeah,
yet to.
so if you did, you can just give requests. No, you can merge without any request because I accept you as a collaborator in the repo.
Yeah, I've been accepted. So I'll just add the resources and then.
Yeah, yeah, cool. I'm gonna share it with the people here.
Okay, great. Um, does anybody else have a question? I think I saw a Ronald hand or Roland.
Yeah, hi. Um,
Hi.
was this question being recorded? A
Yes, it
conversation
was
being recorded.
recorded. Okay, sorry. It was
Okay.
recorded. So at the end of this session, we are going to compile everything with the slides and then share it as well. In the chat box too, I have included all the necessary resources. That's the the blog link that you need to read, the session from the slides and everything from the previous session on Saturday, and the YouTube link about the precision and width and other things. So kindly scroll through the chat box for more information. Leo, do you have the feedback link? Let's just do that.
No, I don't have the feedback link right now. Let me just grab it.
Let me, okay. So
I will
please,
drop it for you. I have it
thank
already
you so
in
much,
the
Imad.
slides. Yeah, I
Okay,
will drop.
you
Awesome.
can. So
Thank you,
please,
Matt.
guys, if you've been on this session and it's been you just click on the feedback link and then kindly give us your feedback on how the session has been for you. Our next session is on Wednesday. It's on Wednesday at the same time, 3 p.m. GMT. That should be 4 p.m. WAT and then 6 p.m. EAT. So hopefully by Wednesday we wouldn't have so much issues. But then Wednesday, basically what we do is that we take more questions instead of like you just try and answer your questions on how the process has been for you so far. So all the best, and then yeah, in the absence of further questions, please do well to fill the feedback, and then yeah. Do you have anything else to add?
So I'm gonna try and be on Slack a lot this evening. So if you have any
Hello,
question, you can just go ahead and drop it in the Slack channel so that
please.
when the answers come in,
I have one last
at this.
question I want to ask.
Sure,
Okay, yeah,
go
I
ahead.
think someone has a
Yes,
question.
go ahead.
I sorry, I don't know if I'm supposed to ask the question here, but I've gone through the project. I've understood the whole concepts that you've mentioned, but my main issue is that I still don't have a partner, and I don't know should I go ahead and just start the project on my own?
Um, so yes, for now, just so you don't waste enough time, you can just go ahead and begin the project. But in the meantime, while you are doing that, make sure you connect with your C17 mentors in your main cohort channel. Or like,
Okay.
have you found a new partner? If you found a new partner, just contact your cohort mentor. So that should be Alfred or Leighton. Contact them and then tell them to repair you with a new person. But in the meantime,
Okay.
you
I've
can start
contacted.
doing the work by yourself.
Okay. What if they connect me with somebody who has already created their own repository? Wouldn't that be a problem?
If the person has already created a repository, then you can come to an agreement as to maybe you can make one of the repositories private so that it doesn't affect the work. Then you get invited on the other repository to collaborate.
Okay.
Does that make sense? Yeah. So
Okay.
when you make it private, then
Makes sense.
it means that, or you can just rename the repository so you don't have conflict.
Okay. Thank you very much.
Okay, great. You're
Just
welcome.
one last. In case if I have somebody I already want to pair with, is there?
Yes,
Can I reach out to the mentor and indicate that I want to pair with that person?
that's the best plan. You have to find someone new. Just give them their details and then they'll pay you.
Okay. Thank you very much.
You're welcome. Okay, thank you all for joining in and do have a good day. Please don't forget to fill the feedback form. Let me see. Yeah, so Ima just shared the feedback form. Put up link. Please do well to fill it up for us. Thank you. Right. If this person's still on there. Someone else the question. Well, Leo, you said you were going to try to be on Slack a lot today. Will
Yeah,
you help out
in the
people
evening. Yeah, I think it's
in
evening
the evening?
already evening for some people, but I mean my evening.
Yeah, it's evening. So,
Yeah,
but like later in the evening.
yeah,
Yeah.
later in the
I mean,
evening.
there are people who are often also looking for help as late as 10 p.m. Ghana time and everything. So still,
Great.
it will be helpful.
Yeah, I see Christian
Okay,
Umo is
so
asking me to explain how to implement the new
who?
line feature. We'll talk about that on Slack.
Yeah,
Okay.
I was checking he was still on the call, but I think he's not on the call anymore. So maybe
Yeah,
you can
we'll handle
respond
that
to
on
him in
Slack.
the meantime.
Great.
Yeah.
All right. Thank you, guys.
So
Thank you, Abina. Thank you, all of you.
yeah, you're welcome. So yeah, we'll talk later. Bye.
Bye.